Forgot to start the recording. Okay, so as I said, for today, you're going to need your growth shield, and there's only one way that it'll fit onto your Freedom K64. You're going to need your growth temperature sensor, angle sensor, also known as your pot. And when you put your growth shield on, as I said, make sure it's very important that the switch is set not at 5, but at 3.3 volts. Now, once you've done that, you're going to connect your temperature sensor. Now, your temperature sensor is a little thing that's about maybe a centimeter by a centimeter, and it's got a little IC on it. And there's a cable that came with that, a 4-pin cable. You're going to connect it. There's only one way it'll connect into the temperature sensor. And then if you look on your growth shield, you're going to find that there is A0, A1, A2, A3. You're going to plug that one into A0. And the growth shield, when you want to connect it up to the pot or the angle sensor, whatever they want to call it, again, it's got a 4-pin connector. You're going to connect that into your pot or your angle sensor, and the other end you're going to connect into A1. Now, the Lab 5 quiz is in the second half of the class, which starts at 3:20 for those people that can't read their schedule. And it will be easy to do Lab Quiz 5 if you pre-do Lab 5 itself. So let's go over some of those important details that I mentioned in the startup screen. So let's go take a look here. So the first thing is let's take a look at your addendum. Now, what we did was we had week 5 weeks of lectures, and then we had a term test and a lab test worth 15%. So when you take a look at your theory portion, you're going to find that I'm considering week 8 here really week 6 of lessons. Now, this week we're doing temperature sensor, which is a thermistor. We're doing analog in API, pot, successive approximation A to D, and so forth, infrared motion detector. We're going to do later, and interrupts we're going to do later, but basically that's what we're going to be covering in the theory, or will have been covered in the theory this week. We're going to take the interrupts that are here and move them down and connect them up with periodic interrupts here. As far as the stuff goes today, the lab quiz is worth 1% of your mark. There's no theory quiz this week, but next week you're going to have to look over all the notes that you've got, and they were just made available today. For LCD functions, sprintf, ticker, for periodic interrupts and interrupts themselves, as well as something called I²C. That should have been put in here, but was somehow left out. Now we're going to do a Grove LCD lab next week. And then the theory of the following week, we're going to start looking at IoT, Internet of Things. We're going to look at big data, small data, SSL, which is secure sockets layer, which is also known as transport layer security, secured chip to cloud communications, device management, pre-commissioning, commissioning, decommissioning, all this kind of stuff, which is part of real world stuff out there. Lab 7, we're going to be doing the 4-digit display and passive infrared motion detector, and we're going to be covering some of that theory around about this time. And we're going to also be looking at, in the theory class, comparison of communication technology, Bluetooth Smart, Zigbee, Wi-Fi, 6LoWPAN, all these kinds of things. And we're going to have an IoT chapter quiz after that, so there will be a bunch of stuff here for video lectures that you'll be then tested on for 2%. And the lab, it says here, is setting up an Ethernet cable. Now, this is probably not going to be done because if time permits, it probably won't be able to be done. It involves you connecting an Ethernet connector from your Freedom K64 to your router, setting up some stuff on the web on io.adafruit.com, which has got a place to actually set up a dashboard where you can have dials and all sorts of stuff that will be updated by what's going on your board. For instance, if you turn your 10K pot, then the gauge on the web page will change according to what you're doing on your 10K pot, and stuff that you do on the dashboard on that web page will then update back stuff on your board. And I think I'll just show you a video on that. I can send you a video link for that, because we want to do is review for lab test 2, because there's a lot of stuff here. So lab test 2, which is not going to be on the very last week, or is going to be on the second last week here. Let's see, when is it? Yeah, it's going to be here on the second last week. So lab test 2 is 15% of your mark. That's a big chunk of it, and it's only going to cover the stuff that we've done in the second half, nothing from the first half particularly. unless it's very simple. Term test 2 is going to cover just stuff that's on the second half. The final exam, though, is going to cover stuff from both halves on theory, so all the practice quizzes, all the chapter quizzes, all that kind of stuff from both sides will show up on here. And one of the things to remember is you must pass both the lab and the theory to pass the course. That's very important. And anybody that usually fails the course usually fails the lab, so let's make sure you get all of that stuff done that you need to make work. Now let's take a look at Lab 5. And there's some videos here on class member functions for analog in class, some details on pod. A lot of these are covered again in the theory portion, and you can do the practice quizzes and look at that kind of stuff later. What you have here is a thing where you're going to click on this link. Now, if you do this before your lab quiz, which is at 3:20, what you're going to do is you can do this stuff because at the bottom here it says, in the Lab 5 quiz, state how many errors you found to correct in this code here. So if you've done it before that, you just write down the number, and when it asks you, there it is. So the thing is, the code that's here is perfect. Now what you're going to find is that there are syntax errors. Now what is a syntax error? A syntax error means that you can't have the program run without changing it because it's an error. And if you compare what you've got, what you've imported here to what's here, you'll see that definitely there's some errors that you should be able to fix up, and then you'll be able to figure out how many errors that is. You are using the pod. It's called an angle sensor. Thank you. Anyway, if you were here at the start. So that's why I'm videotaping this, so you can look at it later. So the thing is, check to make sure that the code that you've got is identical to this. If you do, then you'll know how many errors you have to fix up. Now there's another program here on part 2, where again you click on this link and it's going to have some stuff, but this time what you're going to find is at the bottom it even tells you there are no syntax errors, which means the program will run, but it's not going to run properly, and it's not going to give you results that you should get. And it says how many lines of code you need to change to make things work. Now let's take a look at some of the things that I told you at the start. Make sure you hook up your temperature sensor to A0, right? So that might be some things you want to look at here. And those are some of the things. So there's some things in here that may be an issue. Now when we take a look here, there's voltage equals read. Now input is what we've called here. Let's take a look at on our analog in. Here we've said input 1 is associated with A0. So anytime you say input 1.read, so read is the thing that's going to read. U16 means short, an unsigned short, which means when you read this and it puts it into voltage and you've declared voltage here to be an unsigned integer or unsigned short, what you're going to find is that it's going to give you a number from 0 to 65,535 coming in. And that's why when you do the resistance calculation, it's 65,536 divided by voltage minus 1. Okay, and then the temperature is given by this, because the temperature, as you'll see, and if you've looked at the video in the video section for week 6, it's going to show you that this is not linear, it's a curve. And based on this curve, it's going to tell you a real reading on temperature. And you should be able to see that showing up on your PuTTY screen. So I'm hoping you've got PuTTY set up properly. Now you should have PuTTY set up to be PuTTY translation to be CP437, because when you send it an F8 here or here, you're going to see a degree symbol coming up on your PC screen. So it'll be degrees Celsius, degrees Fahrenheit, that sort of thing here. So again, make sure that when you're running this code, and check this against the one that you brought in to make sure that you're getting numbers that make sense in Celsius. In other words, Celsius should be in your room, should be anywhere from low 20s to mid to high 20s, depending on how hot your room is, but that's what it should say in Celsius. Now, if you remember back to PRG1, you also had 9.0 over 5.0 times temperature plus 32 to convert this to Fahrenheit. So that's all part of what's here. So if you're not getting numbers, make sure, because some people didn't flip that switch from 5 volts to 3.3 volts, which is will cause damage eventually to your board. Make sure it's at 3.3 so your temperature readings are proper. Now on this video here, it's going to tell you that the core stuff that you just downloaded has the documentation not ready thing, because that's what you use in embed. But then what you want to do is you want to clone that, okay? You want to clone that and then get rid of the documentation not ready library and copy and paste in a one that says classes so that you can now export it to MCU Expresso. And it shows you in this video to how to set a breakpoint after it takes not just a temperature reading, resistance reading. And so when you run the program, you're going to get a temperature and a resistance, and you should write them down. It shows you how to do that in the video. Now, if you happen to look at your temperature sensor, it's a little 1 centimeter by 1 centimeter thing with an IC. If you're holding your finger on that IC, it's going to heat it up. So it's going to have 20 point, who knows what the temperature is here, and a resistance value. And then as you hold it and you hit the run button again, it's going to run and give you a slightly higher temperature and a different resistance value. And if you are still holding your thumb or finger on that little IC, you hit the run button again, it's going to stop at the breakpoint and show you another temperature and resistance. And what you're going to find is as the temperature increases, does the resistance increase or decrease? That's something that's very important, because if the temperature increases and the resistance increases, that's called a PTC, or positive temperature coefficient thermistor. But if you increase the temperature and the resistance decreases, then that's called a negative temperature coefficient thermistor. And you have to decide which one that is, okay? Now, the first line of the code is what we looked at just a little while ago, is voltage equals input 1 dot read underscore U16, because that's an unsigned short. And that's why we do this division of 65,536 divided by voltage minus 1. And then it's going to give you a reading from 0 to 65,535. But you can also use just input read without the U16, and that's going to return a float, or you can declare this to be a double float to give you more resolution. Voltage 1 equals input 1 dot read without the U16, and that's going to return a value from 0.0 to 1.0. Now, A to D that you have on here is a 16-bit A to D converter. And so the resolution of both of these is the same, but the output for these is going to be different. This is 0 to 65,535. This is 0 to 1.0. That's why it's 1 divided by voltage 1 minus 0. And the beauty of this particular version here of this is that you can multiply this number by, say, 3.3, and you get the actual voltage from 0 to 3.3 volts coming up on your display. Or if you're driving a car and that indicates your speedometer, it might go from 0 to 100 kilometers an hour, or 200, depending on the speed of your car at max. Mine is probably around 100, that kind of stuff. So let's take a look at the last part here. Now, in MCU Expresso, right, and that's what you're doing up here, is you're doing this business of setting readings and doing all this kind of stuff. So in there, what I'd like you to do while you have that thing is add 2 lines of code at the bottom of the while loop that's in that code. And the 2 lines are going to be position 14, 30 and printf resistance in kiloohms. And so what I want you to do is when you turn the program and use the big blue button, or the blue bug button rather, to compile and download the new version, remove the breakpoint and just run it. Because what it's going to do is as the temperature goes up and down, the resistance is going to be displayed with this line of code here. And therefore, I want you to validate at that point for yourself. As the temperature increases, does the resistance decrease? Yes or no? Well, if it's a positive temperature coefficient, it will be no. If it's a negative temperature coefficient, it will be yes. The thermistor used is an NTC. Is that yes, based on what you've done here? And when the temperature is 25 degrees, did you get a resistance of approximately 100K, yes or no? And I think if I was to give you the answers, anyway, there they are. So that's basically Lab 5. So let's take a look here. And let's take a look at your theory portion here. So under notes for week 6, or video lectures here for week 6, because this is really week 8, but you only had lessons for 1, 2, 3, 4, 5. Then we had week 6 was more of testing. Week 7 was a break week. And so this is really week 6 of our notes. So when we take a look here, here's all the notes that we've got here for analog to digital converter, analog versus whatever. And again, we're going to have practice quiz based on this for week 6 as well. Here's your practice quiz that you should look at all of this information for. Now, what I just posted just a little while ago is the stuff for week 7, which has to do with how the LCD works, Grove LCD connections, program the Grove LCD, I2C communications protocol, and asynchronous. And eventually there will be practice quiz on this for next week before you're going to run into your test, because the test, if you look back here, let's take a look, you're going to find that, where is it here? At this point here, we're going to have a quiz next week, which is going to be based not only on the temperature sensor, but also on the LCD and all this kind of stuff. And it'll be a 2-period chapter quiz next week in theory class. All right, so here's what we have here. Is it says there is where your Lab 5 questions will show up at 3:20. So you got just about 50 minutes or so to try and get through as much of Lab 5 as you can and figure it out. Most of the stuff that's there, you can reference back in your GI section any of the theory content that you need for any of the details of this stuff, but this will appear. You won't see anything in here right now because this I'm looking at it in something called edit mode, but at 3:20 and about 3:18 or so, I'll get your attention again. After I shut off my mic in a minute or so, I'll get your attention again and say, okay, the test has started, go and do it. And if you've pre-done most of the stuff in the lab quiz, or sorry, in Lab 5, you should have no problems doing the lab quiz itself. So let's just switch back to here. Anybody that's come in late, and let's just switch back to here. And there we go. So again, the more important thing that I should mention here is make sure that you've set the switch to 3.3 volts so you don't blow up your microcontroller, and make sure that you've connected your temperature sensor to A0 and your pot or angle sensor to A1 on your board. And those little 4-pin cables, there's no way you can mess that up because they only go in one way. So is there any questions before I let you go? Because it's going to be about 50 minutes before your test at 3:20. And again, there's a 15-minute window that you have to be in to do your test. And that's it for me. So any questions? Just post them in the room. Okay, so I'm going to shut off the video.